Hi everyone, this is Purnima Mahalingam and you're watching video lecture series on solar and wind energy. This is a new series of video lectures on topic of solar and wind energy. And in this topic today we are going to discuss about the modern wind turbine technology which is powering the futures. Come, let's go into the video. Here, first, what we are going to see is evolution of wind power. Merely we know that what is an early windmill, which is used for only for milling grains and pumping waters. So now, in nowadays, we are using for application of power. Okay, here the later 20th century, we are the more modern design, modern technologies have been used. And here since 2000s, that is average wind turbine capacities increases fivefold. So fivefold. Here we can see in the pictures, we can see here it is. This is in starting stage, which is used for milling grains and pumping waters. And early 20th century, they are used for power. And since the 20s, and an average turbine is increased about fivefold. And today, the rotor diameter now exceeds 250 meters. Now the rotor diameter has been exceeds 250 meters. So this is what an this is what an introduction about evolution of wind power. Okay, now here it is. Next one is onshore wind turbine. Here we can see the onshore wind turbine is a groundbreaking efficiency. What is onshore wind turbine and groundbreaking efficiency means? It is the specifications. We have onshore wind turbine, that is specifications are typically 2 to 7 megawatts per turbine, and its height is 80 to 120 meters for optimal wind captures. And main advantages, it is a cost effective due to the mature power supply chains and is easily accessible for installations and maintenance. So example of this type of wind turbine is Vesta V120 162, which is power, which has a power capacity of 6.2 megawatts. It is a popular wind turbine, onshore wind turbine. Okay, now coming here it is onshore wind turbine are efficient and cost effective power generation. Their average establishment infrastructures are reliable. Okay, this is what onshore wind turbine. Now coming to the offshore wind turbine. Here coming to the offshore wind turbine is a capacity of 8 to 18 plus megawatts per wind turbine. Onshore is 2 to 7 wind megawatts. Here it is 8 to 18 plus megawatts of wind turbine. And the wind speed is in a higher, more constant wind yield, that is up to 40 to 60 percentage of capacity factor. And the foundation is a specific modern monopile jackets, gravity based needles, etc. An example is G hailed X, that is 14 to 15 megawatts, which is Siemens company, and Gaiman's SG 14 to 36 DD, that is 14 to 15 megawatts. This one example for offshore wind turbine, which is used recently. And now coming to the uh, innovations. So design, that is design innovations. Now here we are talking about design innovations. What about is carbon fiber? So advanced blade technology design, that is carbon fiber components, that is off strength and lights. And here we have a smart control, that is yaw, pitch and ladder control, late automations powers and digitalizations. Now coming about digitalization, SCADA systems enables remote monitoring, predictive maintenance, and improve drive train, that is drive direct drive generators, and reduces moving parts and enhancement reliability, etc. The innovations are transforming wind turbine capacities. So innovations are transforming wind turbine capacities and increasing the efficiency and reducing the maintenance needs. This is what an innovations which happening in design purpose. Okay, now next one is performance. Coming to the performance and economic impact. So 59 percentage over onshore wind turbine drop, and which is reduced from 2010 to 2022, and 73 percentage offshore drop, that is drop doesn't reduces from 2010 to 2022. Here that is what is an economic impact is 1.25 megawatts global job, 1.25 sorry million global job it's created by the wind energy sector. This is one an economic impact, and this is what the performance of onshore and offshore wind turbine, and the energy wind energy has become one of the most cheapest form of new energy generation, electrical generations, and this economic effects also fuels significant job which is creating globally. So this is about performance increment, and finally we are coming to the environment impact. That is, what about the environment impact? It is main thing is carbon, CO2, CO2 gas, CO2 avoidance is avoid over 1.6 billion tons annually. That is what greater thing is, 1.6 billion ton annually, and it is an energy secured energy and grid solutions with allow battery storage, etc. So this is what an energy contributions and grid integrate. Okay. Now, finally, future of wind energy. The future of wind energy is floating offshore wind and green hydrogen productions, and enhancing recycling and AI-driven operation. Here, this is the main is AI-driven operations. So, predictive maintenance and boost efficiency. So, predictive maintenance is main important, and which boosts the efficiency. These are the wind turbine. So, with this, today we are going to in this video, and in next video we can see in some other topic. Thank you so much for watching.